In this lesson, we'll look at the annuities in present value. In the previous lesson, we looked at the situation where we made payments over time, and then we ended up with a pot of money at the end, which we call the future value. And now there's time. Time machine. And now we're going to look at, like when you take a loan and you get a pot of money from the bank at the beginning, and then you make payments to pay back that pot of money. And we call that the present value. So you get the money now, and this you get the money in the future. All right, so previously we looked at future value in this formula, and we showed that if you were given all the other things, you could solve for future value. Or if you're given all the other things, like except for payment, you could solve for payment. If you're given everything except for n, you could solve for n. So I worked one problem just like each of those. And also we made an assumption that we're going to have everything monthly. So the compounding will be monthly and the payments will be monthly. And this was just a review from last time. So then what about a mortgage? You know that we have the pot of money up front because we get the money from the bank and then we have to pay it back. We can derive a present value formula using the same trick as we did for the future value formula. But I'm not going to do that. I'm just going to give you the formula now because if you really want to geek out over it, it's all over the internet. Khan Academy, and everybody has that proof. And I can show you also if you want me to do it on the side. But to make you sit through it twice is sort of hurtful. So here it is. This is the formula I end up with. It's a little bit different. You can see there's a minus n there. And then there's a 1 minus instead of a minus 1. So it's a little bit backwards from the other one. If you like to see it handwritten, it looks more like this. Sometimes those auto-generated formulas look a little weird. See how that I is written like after the one? It's weird. So it's a strange formula. And then I on the bottom. It's supposed to be an I. Having some trouble making an I. Okay. For payments at the end of periods. And that's the other thing. It's a slightly different formula if you don't make the payment at the end of the period. And so it's kind of like when you buy a house, you know, you have 30 days before you have to make a payment, or sometimes you get the first payment free. And that's, you're actually paying interest all that time. It's not really free. It's just the interest is buried in there. So, okay, so let's assume monthly compounding. And this again, I is the rate divided by 12. And n again is going to be the number of months. It's an annuity problem. So if Joe makes monthly payments of $750 on a 4.25% mortgage for 30 years, how many payments will he make? So we just want to know here how many payments for 30 years. He makes a payment every month. So 30 years times 12 months. And each year, right? Remember this from like old high school chemistry? You say, oh, the years cancel. And it's just 30 times 12, which is 360. Makes 360 payments. Don't list them out 1 through 360. You'll be tired. You won't want to borrow on a house. Okay, so what is the PV of the loan? Well, we say, oh, let's figure that out. We know we have a little formula. 1 minus 1. This is just a calculator exercise at this point. But it is really cool to do. So the payment, we said, is $750. And 1 minus 1 plus, we don't know what I is. What is I here? So I is going to be R over 12. So it's 0.0425 divided by 12. Let's go ahead and do that. I get 0.00354. Close enough. 0.00354. And to the minus n, what is n? N is going to be 12 times 30, right? 30 years. That's that 360 number. So that's where that n comes in here. And then to the minus. See that little minus 360? It's weird raising something to a minus power. And then over 0.00354. So that is not going to be fun, is it? So let's go ahead and see how well I can fit that in. 1 minus 1.00354 to the minus 360 over 0.00354. So let's just give you a little practice entering things in your calculator. How do you enter 1.00354 to the minus 360? That's an interesting question. So what I'm going to do is pull up the old calculator here. I'm going to pull up a calculator and switch over to the emulator. As soon as it opens, it is opening. It's validating licenses. I'm using a free version, so yeah. Okay, and now I just need to switch over to the calculator view. Hopefully you can see that. You see some trash in there from before. All right, and I'll go ahead and clear it too. Okay, so we're trying to do 1.00354 to the minus 360. So 1.00354. Enter that, and then there's a little caret button here. And then I have this little parentheses minus. That's the one you want. See, I hit the parentheses minus for the minus 360 power. And then enter. Don't use this minus. That's the wrong one. Use this one down here. And then it's 0.2802, roughly. 0.2802. Yeah, 0.2802. Okay, so let me switch us back. So we have 750 times 1 minus 0.2802. So got that in there, over 0.00354. And then just taking steps one at a time here. 1 minus 0.2802. That's interesting. Plunk that in there. 1 minus 0.2802. So if you left everything in the calculator and did it just right, you'll get a little more precise answer than mine. But I'm going to, basically I'm rounding here in the calculator so that all my numbers match up in case you want to recheck any one step. And so divide those two and we'll have 750 times whatever that is, 0.7198 divided by 0.00354, which is 203.33. And multiply those two. So 203.33 times 750 is 152. $497.50. So what's kind of cool about that, although it's a little dangerous, is if you're a nosy person and you're just talking about interest rates and your neighbor mentions they have a 4.25% mortgage and it's a 30-year because they say it's a 30-year and they mention that their monthly payment's $750, you might say, oh, they bought a $150,000 house. And you might say, oh, it's hard to find a $150,000 house. I don't even know when you'll be watching this video, but houses have been going up. But you could say if it was $1,500, if it was double that, then you could double that and say, oh, it's about a $300,000 house. So if you have a few key points in your head, like 4%, 750 is 150, or 1,500 is 300,000, you could see how being a realtor, you could just like knock that stuff off, and impress people. So anyway. Moving along, so we have calculated the present value, which means how much his loan amount is when he first starts with 30 years. Now suppose Joe gets down to 100 payments left. What is the PV then? Well, we would calculate it using the same formula. And we sort of think about these things. So, the payment is still $750. And we know that it's 1.00354. And down here, 0.00354. But N now, instead of being 360, will be 100. And what I'm going to do is I'm going to put a little ellipses there. I'm going to calculate it and give you the answer. And then by the last problem in this one, you should be able to figure out what the answer is. I'm going to leave it all in the calculator also. So 1.00354 raised to the minus 100. Helps if I could enter it correctly. Let me switch back to that other good calculator. I don't trust this calculator. All right, so 1.00354 to the minus 100. And then subtract that from 1. And that's interesting. I got a syntax error already. Apparently I'm not as fast as I used to be at this. Right. Oh, this calculator. Okay. to get clever. And then divided by, and then times. So I get about 63,069.10. Somewhere around $63,000. So I'll leave that as a calculator exercise for you. It was very challenging for me. So I know these calculators, they have so many options, they can sometimes be hard now. All right. And I am trying to clear the calculator for the next one. Okay, so, and again, it may seem like we know the payments from our neighbor, but in truth, knowing their payment is a combination of 4 things. And so here's just a little side. If you're going to go into finance, you'll know all about this. You may already know about it. If you bought a house, you'll know. There's these things like PMI, escrow, property tax, HOA dues, and other things. I know, like Hometown is near where I live, and I don't live in Hometown, but it's near there. And they have something called a pansy fee, like for the flowers, like for actual pansies. They actually have a fee every month. They pay for pansies to be planted around. So it's just like crazy dues. How can you avoid each of these things, or let's think about them, like PMI. If you want to avoid private mortgage insurance, if you don't know, when you go to look at a house, study up, and you can learn that here's one way. You take 2 loans, you put 5% down. PMI only happens if you have less than 80%, or more than 80% on the loan, if you put less than 20% down. So if you don't have a lot of money put down, look into a piggyback, which will have a small personal loan with your standard loan. This will be a higher interest rate, but it will avoid the PMI. Of course, you have a little more risk there on your personal credit. And then how can you avoid HOA dues? That's another one. You can think about that. You might buy an older property or something. And then how can you lessen property tax? That is the question these days. In Texas, we're paying about a 3% property tax around here these days. And that's pretty high. In 30 years, that's the value of your house again. So how do you lessen that? And I think as a math person, I say, well, the sure way to lessen that is buy a cheaper house. Less house, less property tax. But other than that, there are some other techniques you could use and think about. Back to working problems. All right. So what is the monthly payment on a mortgage of $100,000 for 30 years at 4.25%? Okay. So it's compounded monthly. That'll always be if it's so monthly payments. See that key phrase? That means it's an annuity. And we want to know, is it a future value or a present value? Because we have 2 formulas. You say, mortgage. There should be a T in there. Mortgage means present value. So this keyword said annuity, and this keyword said present value. And then so we know our little formula. As soon as you know it's present value, I like to think that I know the formula, but I'm going to have to maybe go back and make sure it's the same one we always use, because I did 1 minus in this one. Yeah, 1 minus 1 plus I. Okay. There are several different ways to write this formula that are equivalent. I think this is the easiest over time that I've used. But different books will show you different formulas, but they come up with about the same answer. So then here let's figure it out. Well, the mortgage is $100,000, so we know that much. 5 zeros. The payment we want to know. And then 1 minus. So present value, I'll just write them over here. A lot of students like it when I put the variables on the side. And then and we want n usually. So I is r over 12. That's always going to be 0.0425 over 12, whatever that is. Let's do that on the calculator. This is the same one as we had before, 0.00354. So I was making it easy on us. And then n is going to be 12 payments per year times 30 years. So that's the 360. So often you'll hear loans is 360 or 180 loans. This is a 30 year and that's a 15 years. Common mortgages. So 1 plus 0.00354 to the minus 360 over 0.00354. So it's going to be a little ugly. So it's 100,000 and payment. And all this stuff in here, if we calculate it, So first I'll take 1.00354, and then I'll raise it to the power of 360. That'll give me 0.28, and then I'll subtract that from 1, and then I'll divide that by 0.00354, and I get 203.33. And so our payment is going to be 100,000 divided by 203.33. I know I didn't do each step in the calculator for you and show you, but I want you to practice that on your calculator a little bit. Write on separate paper and take a few more steps. If you need more practice on it, let me know. I'll send you another problem. 491.81. Boy, it makes you want to buy a house. And now I actually saw 30-year rates were at like 3.05%. Crazy cheap. So it's even less than that. So for a $100,000 house, isn't that amazing? Under $500 a month for just the payment. Of course, you know, that'll be $3,000 divided by 12 for the insurance, roughly. What's a monthly payment? And the other thing is, so that's for every $100,000, it's 500. So if it's 500 for 100,000, you can double it, right? For a $200,000 loan, it would be 1,000, right? Double, or double that again for 400,000. Boy, that makes me sick to even think about it. But double that again, maybe 2,000 a month. It's actually not that high a payment, but your property tax on each of those will be 3,000, 6,000. And this would be $12,000 a year property tax on that guy. So before you buy that big $400,000 house, just think about that $500 a month property tax. That'll be pretty high. Anyway, okay, so what is the monthly payment on a mortgage of $100,000 for 15 years? So again, it's a mortgage, and we're looking at monthly payments. So we've got this formula. I'll write it first. I think on the quiz I'll give you the formulas, but you'll see. And then we're going to need the variables in there. That's an N. So PV, payment, I, and N. And just pause it and take a shot at these. So first pause it and put these in, and then check them, and then pause it and do that or whatever. So we know it's 100,000. A great number to start with because you can just figure all the other ones by using tricks. And then the payment we don't know. We want that. I is always going to be R over N, so it's 0.035 over 12. Yeah, I see that I was trying to get things lower for you guys to see now. And then it used to be like 7%. And then N is going to be 12 times the number of years, 15. So 150 plus 30, 180. It's 180 payment mortgage. And this is our period mortgage, 0.035 divided by 12. Plunk that in the old calculator here. 0.00292. So I'm going to just rewrite that as 100,000 equals the payment times 1 minus 1.00292 to the minus 180 over 0.00292. So if you're like a finance major or something, or going in for an MBA or something, they often will go from here to here and add that 1 to the I. So you have the I, they'll say 1 plus I. They won't take a step for that because you should have done it enough millions of times, they figure. And then I'm going to go ahead and do something they do in the books a lot too, which is they'll have something like that. And often they'll just say payment equals. And many times they won't even show you this formula. They'll just be like, the payment would be. So just be aware of that when you're reading books. I know it's not as popular as it used to be to read books, but they can be very useful. So I'm just going to, I'm going to do these steps in the calculator, and then I'm going to put the answer there just so that you can have a little exercise. If you need individual help on that, let me know. But I think on the last lesson, we did quite a few of them. Make sure it's a negative 180 power that you do. And then divided by 0.0292. So I get 139.84. That means, it's an arrow, the payment is going to be 100,000. Well, if it didn't feel like math before, It should now, but you know, this is really cool stuff to do. You can also make amortization tables. A lot of people prefer those to run in the formulas because you see them month by month. And I actually keep one of those, or at least when I had a mortgage, I did, just so I could watch month by month the amount go down. It's terrible at first. It goes down like $1. 715.10 payment, and then just kind of a sanity check. Does that even make sense? It seems a lot higher. So it's a lower rate, which is common for a 15-year to be lower than a 30-year. It's the same amount, but our payment instead of $500 is $700. Well, it saves you 15 years. And if you think about it, how much did you put in? You put in about 500 times $500 payments times 360. So 500 times 360 at the end of the loan is 180,000. You put in 180,000 for a $100,000 house, so 80,000 in interest. And then here you could say, well, what did I put in? You put in 180 payments of 715, so that would be whatever, 180 by 715, 128.70. So 128,700. So here I only paid 28,000 interest, so much lower interest on the 15-year loan. Anyway, just a thought, not just because of the rate, but because you didn't have it sitting in the bank, earning them interest all the time. And then you can also solve for n. So remember a little formula like this. 1 plus I to the minus n over n. And you could solve for either this, or the n. Or the n. So in this case, we're going to solve for the n, and let's figure it out. So we have a present value payment, I and n. So pause it, take a stab at it, and then come back. The present value is 47,61.87. The payment, 350. It's R over 12. So 0.075 over 12. Whatever that is. 0.00625. Oh, I love it when they're even. And then n, we don't know. So we just plunk in the numbers. 47,361.87 is 350 times 1 minus 1.00625 to the minus n over, that's I, sorry, 0.00625. So the first thing is divide both sides by 350. So divide that by 350 and divide that by 350. And over here, we'll get whatever that is divided by 350. It's not pretty. 47,361.87 divided by 350 is 135, etc., etc. So 135, 326.82. And then these are gone. So we have no real need to have brackets anymore. So now multiply both sides by this denominator. Clear that denominator, right? 0.00625. And then over here. So over here they cancel, and we have 1 minus 1.00625 minus n. And then you have to multiply the things on the right side. Helps if I'm on the calculator. 845 point something. 79. Yeah, okay. And then subtract 1 from both sides. It's kind of weird. So we have 844.79. Multiply both sides by -1. Not feeling good to me. And then what else do we have? Yeah, okay. What I'm baffled by is how 47,000 divided by 350 gives us this big number. There's the error. There's the error. Okay, so when you divide that by 350, you should get a different number. So let me try that again. 47,361.87. 47. Oh, I see what I did. I hit a number too many times. I made a mistake, my bad. So it should have been 135.32 equals 1 minus 1.00625 to the minus n. So now multiply both sides by 0.00625. And over here we have 1 minus 1.00625. So you'll know something's fishy when you get down here if it doesn't match out. So nothing like watching the professor make a mistake. 135.32. At least I caught it before I published this thing. 0.84575. And now we can subtract 1 from both sides and see something interesting will happen. We have minus 1.00625 to the minus n. And over here we have, subtract 1 from that. We have minus 0.15. So minus 0.15425. Now, these are both negative things. So I'm going to multiply both by negative 1. And we'll get 0.15425 equals 1.00625 to the minus n. Kind of important that you do that before you fiddle with this minus n, because it's, yeah. This is minus this to that power. So first exponent, then multiply. It's kind of weird. And then you see, take log base. Let's just go here. Log base 1.00625 of 0.15425. And that equals log of that base of that should just be minus n. So then we have natural log of 0.15425. The change of base formula. This is that same thing. So now we can use calculator to calculate that. We get 0.15425. Take the natural log of it. We divide by the natural log of 1.00625. And we get minus 300, roughly. So n is 300, which is 25 years maybe? 300 divided by 12. 25 years. So months. 300 months, 25 years. So it's a 25-year loan. It's a weird one. Or that's how much time's left if you looked at it. It said how much time left. And then again here, you could look at this and say, well, this guy here, sometimes when you set him up, check the interest. It's $60,000. And it's 7.25% interest. And if you check that, you'll get 362.50. So you can see the first month's interest is higher than the payment. And so you will never be reducing your payment. It'll just go up higher and higher. And you might say, well, how would you know to look? And if you set it up this other way and you solve down there and you get something that doesn't make sense, that's how you know. So, but sometimes they'll say, what's the interest? What's the minimum payment? This is the thing they usually often ask. And you'll just take that amount times the monthly I, if you will. And then that'll tell you the minimum payment has to definitely be at least that much. So at least 365, to have a chance. And then if you're making the payments on the house, you might say, well, it better be at least 400 or 450, or I'm going to be like paying long before I'm in the grave. So here's one where it's a problem for you to solve. So what's the minimum payment? Here's a good problem like I like to give. So to keep from sinking, that's called sinking when you go upside down in the house like that. So you have 24,000 times I. Remember, I is R over 12. So it's 24,000 times 0.08 over 12. And just multiply that out. It's super easy. So 160. So if somebody gives you a loan of $24,000 and they only want to charge you $100 interest, just say no, because what they're trying to do is basically enslave you into infinite debt for the rest of your life. if you make the minimum payments. So just make sure your minimum payment in this case is above 160, like 200 or something. It could be 161 and you'll eventually get there. All right. And this is just describing what I did, I think. So whatever. Anyway, that's it for the lesson.